Welcome to Chapter 3 Forensic Methods and Labs. This is your Professor T. Fareed Muhammad. Let's begin from where we left off in the last lecture. So, here are a few forensic methodologies. Let's look into these together in a little bit more depth with one example each. In digital forensics, minimizing interaction with original data is paramount to preserve its integrity and admissibility in legal proceedings. The first step is preservation, where the device, such as computer or hard drive, is immediately isolated from any network or power source to prevent further data changes. A writer blocker is then employed to ensure no alterations occur during the acquisition process. Next, a bit for bit copy of forensic image of the original hard drive is created using specialized tools like FTK Imager, NCASE, or DD. This image includes all data, metadata, and unallocated space. Cryptographic hashes such as SHA-256 or MD5 are generated for both the original drive and the forensic image to verify data integrity and confirm that the copy is an exact replica. All subsequent analysis is performed on the forensic image, leaving the original data untouched. During the analysis phase, investigators use dedicated forensic software suites like FTK, NCASE, or Xways forensics to examine the data, extract artifacts, and build a timeline of events. A detailed chain of custody is maintained to track the movement and handling of the original evidence, and all steps taken during the analysis are meticulously documented. Finally, clear and concise reports are generated to summarize the findings for presentation in court or to other stakeholders, ensuring that the original data remains unaltered throughout the process. So now let's look into comply with the rules of evidence in a little bit more depth. Complying with the rules of evidence is crucial to ensure that the findings are admissible in legal proceedings. This involves adhering to strict protocols and standards throughout the forensic process. Firstly, maintaining a proper chain of custody is essential. This involves documenting every person who has handled or had access to the evidence from the moment it is seized until it is presented in court. Each transfer of custody should be recorded, including the data, time of the last acquisition of the data, date, reason for transfer, and the names of signatures of the individuals involved. This meticulous documentation helps to establish the integrity of the evidence that and prevent allegations of tampering or mishandling. Secondly, following established forensic procedures and guidelines is virtual and technically also vital. This includes using validated tools and techniques for data acquisition, analysis, and reporting. Forensic investigators should adhere to internationally recognized standards such as those outlined by National Institutes of Standards and Technology (NIST) or International Organization for Standardization, or also known as ISO. These standards provide a framework for ensuring the reliability and accuracy of forensic methods. Additionally, ensuring the competency and impartiality of the forensics examiner is crucial. Examiner should be properly trained and certified in the field of expertise. They should also maintain impartiality, avoiding any bias or preconceived notions that could influence their analysis or conclusions. Peer reviews and quality assurance measures can help to validate the examiner's work and ensure that it meets the required standards. Furthermore, proper documentation and reporting are essential for compliance with the rules of evidence. All steps taken during the forensic process should be thoroughly documented, including the tools used, the method applied, and the findings obtained. Reports should be clear, concise, and understandable to non technical stakeholders such as lawyers, judges, and juries. They include also, let me retrace, they should also include any limitations or uncertainties associated with the analysis. Lastly, complying with legal and ethical standards is paramount. Forensic investigators must obtain proper legal authority, such as search warrants or consent, before accessing and analyzing digital data. They must also respect privacy rights and maintain the confidentiality of sensitive information. Failure to comply with these standards can result in the exclusion of the evidence in the court and potential legal or ethical repercussions. By adhering these principles and guidelines, digital forensics professionals can ensure that their work complies with the rules of evidence, therefore enhancing the credibility and admissibility of their findings in the legal proceedings. So let's also look into avoiding exceeding your knowledge. It is crucial to avoid exceeding one's knowledge and expertise to maintain the integrity of the investigation and the credibility of the findings. The principle is essential for ensuring that evidence presented is accurate, reliable, and defensible in legal proceedings. Recognizing the limits of one's expertise is fundamental. Forensic investigators should be aware of their own knowledge and skill levels and refrain from performing tasks or drawing conclusions that are beyond their competence. This self awareness helps to prevent errors, misinterpretations, and potential challenges to the evidence in the court. If a task requires specialized knowledge or skills that the investigators lack, it is essential to seek assistance from qualified colleagues or external experts. Next, staying up to date with the latest developments in the field is vital. Digital technologies and forensic methodologies are constantly evolving, and new tools and techniques emerge regularly. Forensic investigators should engage in continuous learning and professional development to maintain and enhance their knowledge and skills. This can involve attending training courses, workshops, and conferences, as well as reading relevant literature and engaging with professional communities. Last but not the least, create an analysis plan. Let's look into this in a little bit more depth before we go to the next slide. Creating an analysis plan is a critical step in digital forensics that ensures a systematic, thorough, and efficient investigation. Before commencing an examination, it is essential to develop a clear and structured plan outlining the objectives, scope, and methodology of the analysis. This proactive approach helps focus the investigation, prevent oversight, and maintain the integrity of the evidence. So, creating an order of volatility. Examples of the order of volatility: registers and cache, routing tables, ARP cache, process table, kernel, statistics and modules, main memory, temporary file systems, secondary file systems, router configuration, and network topology. RFC 3227 guidelines for evidence collection and archiving in order are volatile data, file slack, file systems, registry, memory dumps, and system state backup internet traces. These all are the features where we can get help in terms of the analysis plan that we have just discussed. The analysis plan should begin with clear definition of investigative objectives. Few are given here. These objectives should be specific, measurable, and aligned with the goals of the case or incident. For example, the client might aim to identify the sources of data breach, recover deleted files, or analyze user activities on a system by explicitly stating the objectives, investigators can prioritize their tasks to allocate resources effectively as discussed in the slide. Additionally, the plan should outline the scope of the analysis, including the device's data and time periods to be examined. This helps to set boundaries for the investigations and prevent unnecessary or irrelevant work. Technical information collection consideration: consider a lifespan of the information. Data is volatile. Collect information quickly. Collect bit level information. The analysis plan, as we are discussing from the previous slides, should detail the methodology to be employed during the investigation. This includes the tools, techniques, and procedures that will be used to acquire, analyze, and interpret the digital evidence. The plan should follow established forensic guidelines. The best practices, such as those outlined in the National Institute of Standards and Technology (NIST) or the ISO, as mentioned earlier. It is crucial to use validated and reliable tools and methods to ensure the accuracy and credibility of the findings. The plan should also outline the order in which the tasks will be performed, ensuring the volatile data is captured first and prevent the loss or alteration. Formal forensic approaches are Department of Defense Cybercrime Chapter DC3 forensic standards. I would suggest you to look into that in your given text to read. The Digital Forensic Research Workshop or DFRWS framework. Scientific Working Group on Digital Evidence is the SWGDE framework, event-based digital forensic investigation framework at Purdue University. So this is going to be very helpful for you. So again, let's continue where we left in the previous discussion. The analysis plan should address quality assurance, documentation, and reporting. This includes measures for validating the results, such as peer reviews, cross-verification of findings using different tools and methods as mentioned on this slide. Let's go to the next one. Documentation and methodologies and findings. Strong evidence processing documentation, good chain of custody, and procedures. So by developing and adhering a well-crafted analysis plan, as we are discussing with the features and all these other ingredients, digital forensic professionals can approach investigations systematically, minimize errors, and enhance the overall quality and credibility of their findings. Find, preserve, and prepare. Gather evidence, as discussed earlier. Work in secure laboratories to isolate data and avoid contamination. Preserve, handle computers and storage media with caution. Prepare, document evidence source and ensure evidence has not changed. Avoid changing the evidence gathering measures. Determine when evidence was created. Trust only physical evidence. Search throughout a device. Present the evidence well. Expert reports. Formal document that details expert findings, often filed in a case prior to the trial. Considerations include format of the report, thoroughness, backup of everything you say. Equipment. Have adequate equipment for the job. Have sufficient storage for the data. Must have redundancy. RAID 5 is recommended. Have a variety of computers capable of attaching various types of drives. Have power connectors for all types of smartphones, laptops, routers, and other devices. Security is significant. Machines being examined should not be connected to the internet. Lab network should not be attached to the internet and should be separate from working network where you check email and use the internet. Lab rooms should be shielded from electromagnetic interference. Physical security is limited. Lab access and secured. Windows and doors should be in the room where you're conducting your R&D. American Society of Crime Laboratory Devices, or ASCLD, provides guidelines for managing a forensic lab. Acquiring crime lab and forensics lab certifications certifies computer forensics lab that analyze digital evidence. A lab must meet about 400 criteria to achieve accreditation. Typically takes 2 or 3 years to prepare for accreditation. Includes audits to ensure correct and consistent procedures. Tempest programs, Department of Defense guidelines on electromagnetic radiation EMR is also significant. Common forensic software programs are EnCase, Forensic Toolkit FTK as discussed earlier, OS Forensics, Helix, Kali Linux, and the list goes on. EnCase would look like this. EnCase view pane gives us all the details, including JPEG, paid PDFs, and all that jazz. EnCase search allows us to set the priorities, adjust the configuration to go and find the details. FTK, or forensic software programs, allow us to write a configuration for us to conduct R&D in a little bit more depth. Email analysis is also given here, so you can look at that how emails can be analyzed on top of the material that they had. So you can see Frodo Baggins, eBay, and Frodo Baggins again. Autopsy is another way to find all the deleted files in the search drive, and the images are captured to figure out what exactly was happening within the machine. Certifications, the CompTIA Plus is for PC hardware, basic networking CompTIA Network Plus, or the Cisco Certified Network Associate CCNA, technically CCNA. The security of CompTIA Security Plus and or ISC2 CISSP certification. That is the one which I suggest you to all to do. That CISSP is significant and is needed when you go apply for these jobs. Hacking, EC Council Certified Ethical Hacker, SANS Global Information Assurance Certification, or penetration testing is also important. Now let's look at this in a little bit more depth. Forensic certifications, that why these are needed and how you can go for it. The EnCase Certified Examiner certification is a highly regarded credential in the digital forensics community, demonstrating an individual's proficiency in using EnCase software for computer investigations. Offered by OpenText, this certification validates the holder's ability to perform comprehensive digital forensic examinations, including data acquisition, analysis, and reporting. To obtain this certification, candidate must pass a rigorous exam that tests their knowledge and practical skills in using EnCase tools and applying digital forensic best practices. This certification covers a wide range of topics, including file systems, data recovery, email investigations, internet history analysis, and report generation. Candidates are required to demonstrate their understanding of digital forensic principles as well as their ability to use the software to analyze and interpret digital evidence. This certification is designed for professionals working in law enforcement, incident response, and corporate investigations, among other fields. By earning this certification, include individuals can enhance their career prospects, gain recognition in the digital forensics community, and increase their value to employers. Prior to ensuring this certification, candidates can benefit from gaining hands on experience on the NCASE software through real world use cases. For example, consider a scenario involving a suspected inside threat within an organization. An employee is believed to have exfiltrated sensitive data to a personal email account. Aspiring NCASE candidates can practice using NCASE to investigate this incident by performing tasks such as imaging the employee's workstation, analyzing file access logs, recovering deleted files, and examining email artifacts. They can also learn to generate timelines of events, identify relevant evidence, and document their findings in a clear and concise report. By working through such use cases, candidates can develop the practical skills and knowledge needed to excel in the certification exam and effectively apply NCASE in real world digital forensics investigation. This hands on approach not only prepares candidates or you if you are going to take this exam for the certification, but also equips them and you with the expertise to handle complex digital forensics cases in the professional career optimization. Next, I would suggest you to look into Access Data Certified Examiner, OS Forensics, EC Council Certified Hacking Forensic Investigator, and Global Information Assurance Certification certificates. So this will allow you to learn more how to do the forensic certifications and apply them in the real life. In this lecture, we have looked at all these topics in a little bit more depth. I would suggest you to apply that in the course so you understand exactly what you are conducting in terms of experimentation and learning techniques. The evidence handling tasks is something more that I would like to add here. So you are going to use evidence handling tasks in more better way. Proper evidence handling is a critical aspect of digital forensics, ensuring the integrity, admissibility, and reliability of digital evidence. Evidence handling tasks include the preservation, collection, transportation, storage, and documentation of digital evidence. Preservation involves isolating and protecting the evidence from alteration or damage, while collection focuses on acquiring the evidence in a forensically sound manner, such as creating bit-for-bit images and storage devices as mentioned earlier. Transportation and storage requires secure and controlled environments to prevent tampering or loss. Documentation is crucial throughout the process as it establishes the chain of custody, tracking the movements and handling of evidence from the moment it is seized until it is presented in the court. One example of evidence handling tasks is a seizure and examination of suspect's laptop in a cybercrime investigation. Upon arriving at the scene, investigators must first isolate the laptop to prevent any further changes to the data, such as disconnecting it from the internet and power source. Next, they use a write blocker to create forensic image of the laptop's hard drive, ensuring that the original data remains unaltered. As discussed earlier, the laptop and the forensic image are then securely packaged and transported to the controlled evidence storage facility. Throughout this process, investigators meticulously document each step, including the date, time, location, and individuals isolated in handling the evidence. This detailed documentation helps to maintain the chain of custody and ensures that the evidence can be authenticated and admitted in legal proceedings. By following these evidence handling tasks, digital forensics professionals can preserve the integrity of the evidence and support the successful prosecution for cybercrimes. Hope to see you in the next lecture.